Hey guys, today we're going to be talking about writing parallel and perpendicular equations. So we just did a whole bunch of graphing and now we're going to focus on parallel and perpendicular lines. So what this means is that given an equation, you're going to have to create another equation that's either parallel or perpendicular to a line passing through a certain point. So let's recap a little bit. You guys learned about this last year. Let's just rethink about it a little bit. The parallel equations, they're going to have the same slopes, right? If you think about it, they're both rising and running at the same exact rate, so they're never going to touch. That's what parallel lines mean. They're never going to intersect, so their slopes have to be the same. Perpendicular lines, they cross at a 90-degree angle. So in order for that to happen, their slopes must be opposite reciprocals. Okay. So what this actually means is that they need to be opposite. So if one of them is 1/2, the other one's going to have to be negative. Now, reciprocals, what that really means is that they're going to be flipped. So if you have the slope of 1/2, if you flip that, that's really -2/1. So these two here would be opposite reciprocals of one another. The same thing if I gave you 3/4. The opposite reciprocal would be -4/3. Same thing if we talked about just the plain number -3. Opposite reciprocal of that would be a positive 1/3, because remember, a whole number can just be written as a fraction as 3/1. All right, so if we look here at our first section, we are talking about writing parallel equations. So write the equation of the line that passes through the point -2, 7, and it's parallel to y equals -4x plus 1. The only thing we are concerned about in this equation that's given to us is the slope. The slope here is -4. So it's giving me a slope of -4, and then it's giving me a point of -2, 7. So if it's giving me a point and a slope, hopefully you guys are thinking, oh, point slope form. So going back to point slope form, that was y minus y1 equals m parentheses x minus x1, where you're only plugging in for the y1, the m, and the x. So we have our x1 and our y1. So we can now go through and substitute, right? I can have here y minus 7 equals -4, x minus -2. Don't forget that minus and negative. We're going to clean that up there, and we're going to make that +2. Okay, from here, you're just really solving. I want to now distribute that -4 in. Y minus 7 equals -4x minus 8. Add 7 to both sides, and you get y equals -4x minus 1. That is your equation, okay, that is going to be parallel to the equation that was originally given to you, and it's going to go through the point -7. So you could check this by graphing it if you really wanted to, but that's not always necessary. Okay, let's take a look at example number 2. Write the equation of the line that passes through the point 3, -1, and it is parallel to the line x minus 3y equals 9. So if you think back to what we did in example number 1, we looked for the slope here, but we have a small problem. We can't identify what the slope is of the equation as it's given to us. So instead, we need to take that and we need to get it into slope-intercept form first. So again, we just did this. Slope-intercept form is y equals mx plus b. Subtract your x. Divide by your -3. So you get a 1/3 x minus 3. Okay, so now I can actually look at this and I can go, hey, right here's my slope. My slope is 1/3. And hey, they gave me this point, 3, -1. So now I'm right back as where I was before as example number 1. And I can substitute all of this into point slope form. I minus y1, m parentheses, x minus x1. Okay, so I want you to please pause the video All right, and I want you to take this information and substitute it in here, okay, and get it into slope-intercept form. All right, so hopefully you went through and paused the video. Your final answer here should be y equals a 1/3 x minus 2. Okay, going through just a few things. Did you remember this minus a negative? Did you clean that up to be a plus sign? And then when you go and distribute here, you get a -1. Subtracting 1 gives you your -2 here as your y-intercept. Okay, so go through and check your work there. Moving down to perpendicular equations. Perpendicular equations work basically the same way. We just need to remember what we wrote up top here is that our slopes for perpendicular equations are going to be opposite reciprocals. So that is going to come into play here. So if we look at the equation given to us, it says write the equation of the line that passes through the point 4, 3 and is perpendicular to the line y equals 2x minus 4. So we can see here, first thing we want to see is the slope. Our slope is 2. All right, but instead of just taking that slope and using it, we need to remember perpendicular. Perpendicular slope, opposite reciprocals. So I need to take the opposite of 2, which is negative, and we also need to flip that. Remember, that's really 2 over 1. So our new slope needs to be a negative 1 over 2. And then it's still going through this point, 4, 3. So once we have that information, you have a point, you have a slope. So we're plugging it into point slope form again. Again, pause the video, and I want you to try substituting this information into the correct spot and getting it into slope intercept form. Hopefully you pause the video, and you can see here that your equation of your new line should be y equals a -1/2 x plus 5. This line would be parallel to the one that's given to us in our problem, and if we would graph it, it should go through the point 4, 3. Moving on to our last example here, write the equation of the line that passes through the point -5, 1 and is perpendicular to the line 5x plus 3y equals -21. So hopefully this is looking familiar, right? Like the example number 2, that the equation that's given to us is not in slope-intercept form. It needs to be in slope-intercept form. So pause the video, get this into slope-intercept form, please. All right, so our equation is y equals a -5/3 x minus 7. The whole point of that was to identify what our slope is, and our slope here is a -5/3 x. But remember, we're talking perpendicular, so I can't just pull that out and be like, oh, I'm done, that's my slope. I need to take the opposite reciprocal of that. So the opposite, meaning it's going to be positive, and I need to flip that, so it's going to be a positive 3/5. And then it's going through the point, -5, 1. So now you can use that information, and now you can go back to your point slope form. So again, pause the video, substitute this information in, see if you can get into slope intercept form. All right, so taking a look here, we should get as our final answer y equals a 3/5 x plus 4. Just a few things as a reminder. Again, you had this minus negative here. Did you clean it up? Please clean it up and make it a plus before you go and try and distribute. Okay, if you try and distribute up here before you clean this up or try and do it all in one step, it gets very messy and it doesn't always work out. So go through and clean it up first, then distribute your 3/5 in. Bring your 1 over, and you should get y equals a 3/5 x plus 4. So those are our notes, guys, for parallel and perpendicular lines. Hopefully you are going to watch the graphing linear inequalities video next. Take notes on that. And then you do have some book pages to do as well. Please pay attention to the due dates. If you guys have any questions, please make sure you're reaching out through email or joining a Wednesday Zoom session. I will see you guys back in class. Thank you. See you later.